Welcome to second class of 12th class board examination. So first of all, I will like to share with this screen because many of the students have the misconception that density is directly linked with the refractive index. So see, here I have just taken a screenshot that the refractive index of light rays are passing through encounter the homogeneous medium, and the refractive index of oil, you can see, I guess I have not taken out this refractive index of oil is 1.51, isn't it? You can see here, very nice. This 1.51 is a refractive index of oil, and here you can see that water that air is 1, whereas the density of oil is almost, I guess, approximately 0.9, and the water is 1. So you can see that there is a clear cut difference that density is not directly linked with refractive medium. So it's just a concept that I want to tell you. So let's start with the actual thing that I wanted to know you is. Okay, so today, as I said, that today we will do the derivations of class 12 ray optics, which is basically concerned in board examinations. So let's start it. Ray optics derivation. Today our purpose is to do only derivations regarding ray optics, and for that I will do the first derivation, which is a very basic derivation, mirror formula. So before we start with the derivation, we should know the sign convention. Otherwise, if I do, you won't understand. So we will do the mirror formula derivation, but first of all, before proceeding into it, the first thing we will take into action is sign convention. See, this is so this is the focus, and this is the center of curvature. Here, this is the focus. Sorry. I'm really sorry about it. It's not the focus. Yes. So this is the focus, and this is the center of curvature. So the first question comes to our mind is that this curvature. Many of the students were thinking that here also we can determine the focus at the C and F, and here also most of the people are thinking that why this focus in here exists, why not here, or why it exists here, why not here. The simple reason behind is, if you extend this part, if you extend it, if you say you extend this like this, we just extend it like this, and here you extend it like this. So this will be the focus, this, because the sphere will be like this, and here only the center of the sphere will be taken place, and here also like this. So the focus, and I guess you have cleared the concept of in which direction you consider center of curvature and focus. Now without wasting any time, I will just go with sign conventions. I will just write what are the sign conventions here. This is a mirror. This is mirror. This is exactly same. I don't think so that you need to memorize it. In Cartesian plane also similar is followed. This is positive, whereas the left hand side is considered as negative and the down side is considered as negative. Now, when we take consideration into mirror, so as you know that this is positive and negative, and here this is a reference point, isn't it? This point is the reference point, something like this. This is the reference point. And from here only we can consider it is similar to the concept of origin, that somewhere you are considering the direction. Similarly, in concave mirror or convex mirror, this is taken as origin. You know that this pole, this is the pole, this is the pole, and this is the pole, and this is only the thing which is taken as origin in sign convention. So if any ray, say this ray is coming like this, so since this is the origin, so we can easily say that this is positive, this direction is negative. Consider this is an origin, and this is negative, and this is positive. So I will just, you know this, and I will draw with a diagram to explain it better. So, as you know that in ray optics, the direction of the light in which it is going, it is taken as the direction of that light. Means, say, this is an object. This is an object. consider this as an object which is placed in front of concave mirror. So this part is positive. Why? You must remember this one. This, you remember this is the reference point. So up is down and this is negative. So since it is upward, so this is positive. No doubt in this. I don't think so it has any doubt. So we can write it as positive. And say the image is formed here. The image is formed here. This is the O and this is the I. This is the I. This image, as you can see, wait, I will draw a different color. So the image is, say this is the image. Say inverted image is formed. So this is negative because this is the positive one. Now assume that this ray of light from this object is coming like this. This. So this is taken as positive distance. And when it reflects back by passing to the focus, I will show you the exact ray diagram only. Wait. Show you the where actually the object is formed, so that it will clear the concept for me. You understood sign convention. Now I will just give you an example to show that how it is actually applied and where the focal length is taken positive and negative. So consider this as a convex mirror and we'll just draw the this part is F and this is C. Like you have understood sign convention, and I will show you that how it is actually applied. This is an object. This is an object which is placed beyond F. This is the object. This is object which is placed beyond F, and this is the focus. This is the object. And this is actually an object O. I will just draw a, let me draw a ray diagram. What has happened? Ray diagram. Yeah, this is the ray diagram. Yeah, that's exactly fine. This is our ray diagram. This is our front tip of the object. We are going to draw a ray diagram. This is our actual ray diagram. No, this part. This is our ray diagram. And now, as you know, that it will fast to focus according to the rules. So, ray diagram rules, it is fast to the focus. So let me pass it through focus. Okay. Now this is the one diagram, and now my wish is I will do like this. What I will do, I will just, instead of passing the focus, I will just let it pass through. You know that there are two things where we require these two objects, because where 2 points meet we can easily get an object. So it depends on our choice that we want the ray to fall on pole or we want the ray to fall on focus. So here I will just choose to fall the ray on pole. I will just make it fall on pole. So let it flow on pole. Fine. This is the one and this is the one. So let me check how much degree it is. It is approximately 24 degree. Okay. So I will just 26, 25, 24. What I will do is I will just do like this. Okay. So see here, this is the convex lens, and here we have just drawn an object and it has appeared to pass through focus. Ray diagram. Okay. Now we will draw the another ray diagram, that is now let's take the second ray from convex mirror of like this, that it appears to pass through center of curvature. So what I will do is, this is a second ray. This is just appear. So it's 12 degrees, so I will just do it 12 degrees. Same concept, nothing will happen. This will so here see, as you can see here, that these lines in real will never meet each other. Is it possible? Never. It's not at all possible. So it's the only one condition is possible, that it is formed virtually. That you can see that this, let me draw the image, that is the obtained point. This is our image. You can see the intersection point. This is our image. This is our image. This is our eye. So here also you can see that image is also positive, means this positive, and here the focal length, you can see this focal length here is positive, because here I have taken pole as a reference, and this also, this direction is positive, no issues. Consider direction. This direction is positive since it is going from right to left, left to right, and from focal distance is positive, and this erect and virtual image is formed here. You can see that it is, the size is always smaller than the size of object, size of image. So it's clear cut definition. So in summary, we can say that positive sign means that it is either height is, image form is image erect, and other condition can be and the second property which can see is the image is erect and then it is also virtual, isn't it? It's not really formed, but it's virtually formed. Whereas if negative sign means that image is inverted, And of course the second property is also satisfied, it is real. This is all about the convex mirror. Now I will just focus on the convex and concave mirror we have talked about. Now I will just talk about lens. What happens in case of lens? Wait, I will just do one thing. I will draw two lens here, concave and convex. And remember, these all ray diagram I have drawn, I am considering lens of mirror is more denser than the object. This lens I am talking about. So here the ray diagram may differ as you have seen in previous question, but I am just taking a general case to make you understand. The focal length always remains the same. You need not to worry about the focal length. Yeah, the image and the positive signs may change. So let me draw this one. Let me draw the this is our lens. We are talking about thin lens, so I will just do thin lens. This is our concave lens, convex lens, and this is our concave lens. This is our concave lens. As simple as that. Wait. It's not that nice. Wait. This is our concave lens. Assume that this is a concave lens and this is convex lens. This is convex and this is concave. Now I will draw the F1 and F2. Here we are not drawing central curvature, we are drawing F1 and F2 since this lens is not opaque. It is either polished. So here we will just consider F1 and 2F1 or F2 or 2F2. So firstly I would like to take the example of convex lens where this is our optical center and this is our optical center. Consider this as this is a reference. Considering this as an optical center, this as my optical center. And from here only we will start to count the F and 2F. So as you can see here, we can see F. Here we can see 2F. So we'll just mark it off. F1 and 2F1. Here also we will mark it as F2 to F2. This is it. Don't know why it is happening. This is 2F2. So first I will take the example of convex lens. So I will just zoom it and I will tell you that what happens actually. Let's assume an object that is placed here. Wait. This is an object which is placed. A little bigger. This is an object. Now I will just draw its ray diagram. We know that according to this ray diagram, and this will go like this. And one more thing, many of the questions will many of the students might be thinking that here till here we are assuming the ray is coming to be straight, but here it has entered the medium called glass, so it should bend. Yeah, your doubt was exactly correct, but what we do is here we are considering all the lens as thin lens or thin lens or thin convex lens. So in this we will just consider it as thin, and for thick lens and thick lens this will not comes out to it through, and the ray diagrams of that will be different. I will not discuss thick lens here because it is not concerned from the board point of view. So I will just consider it as a thin lens, and we can consider that deviation can be negligible. So this is the basic assumption we do. That's why I am letting you know that. Now this is the ray diagram, and now I will just make it to pass to focus. This is okay. This was our focus. This is the F1. So I will just make it pass the focus. Let me have this pass. Wait. This is an object pass to the focus. Now I will just make it pass to the optical center, and it will pass straight to it according to the sign conventions. The rules of the ray diagram. So this assume this will just pass to optical center. Fine. Now it is like this to this and like this. So now this is our image form. As you can see that this is our image this is our image, this one. This is our image, this one. This is our image. This was object O, which was taken as positive. This is our image I. This is taken negative. Now the first question which comes to our mind is, here what is the focal length of convex mirror, convex lens? See, here the situation is something different. This is formed, this is formed by help of this, and this is formed by this, isn't it? Fine. So since O is considered as a reference, the concept is very easy if you have focused on first one. See, there are two spheres. This is one. Actually, lens is formed by the combination of two glasses, and this is the first one, and this is the second one. Okay. So here I have considered this as a reference. Means you can say that this F2 and this is also F1. So you can say that this is our reference point. So if we will go like this, and if we will go like this, so this is from O, central points, this will be negative and this will be positive. So that's why if we are considering the distance from here, if we are taking the, if we are considering the focal length F2, if we are saying F2 and this is F1, so F1 will be negative and F2 will be positive. Fine. I hope so that it's clear of the convex lens. Now I will just proceed on to concave lens. Same concept, everything is same. If you have understood concept, it's all same, but I will still make you understand the concave lens, how we will proceed. Now how can we identify it? Wait. First of all, let me draw this black line. This is the axis, pencil axis. Okay. Pencil axis I have drawn. Now just mark it the focal length. Okay, I am considering 0, this one. This is our F2. This is again a reference point. Now this is our F2. This is our F1. Wait, similar to this case, this is our F1 and this is our 2F1. These are 2F1. I will write it more better here. 2F1. This is our F2. And this is our 2F2. Now let's draw the imaginary surface that we have drawn, imaginary part. And just this is our imaginary part 1, and this is our imaginary part 2. So here this is our basically the center and this is our center. as I told you, this is our reference point. So now I will just draw a ray diagram and I will explain you with that help of that only. So consider an object placed here. Say it is placed beyond 2f. Let this object be placed beyond 2f. This is our object. This is our object which is placed here. O, which is positive. Which is positive. No doubt in this, I guess. Now we will, according to sign convention, we will just draw it. Make it back. Now since we know that it is a concave lens which is a diverging lens, considering glass as a refractive, considering glass and surrounding medium as air, so it will diverge. So but the principle will remain same, that it will pass through focus. So virtually it will pass to focus. So we'll just make it pass to focus. Wait, I will just make it pass to focus. It's a diverging lens, so just do like this. If I will do like this, it converges and just pass to focus. When it is focus, it can diverge. Let's go like this. Where? Clear? And this will be like this. We'll extend it. It appears to pass to focus. This is our first ray diagram. Our second ray diagram will be the center of curvature one. So we will just make it pass through O. We just make it pass through O, because as per the ray diagram it will pass straight to it without deflection. Let the second image, second light would be like this. Fine. Now here you can see that this is our formed image. This is our new image formed. I'll just magnify it and tell you that it's a small image, but it is formed here. See, this is our new image which is formed, and which is formed at the intersection of this yellow line and this virtual extended one. So this is our image I. This is our image I, and whose sign is also positive. Whose sign is positive. And now see, here also the same concept applies. The concept behind it is this, that here F2 means this one. This is the positive one, since it's like this, so I will just draw it like this. This is the positive and this is the negative. It's clear cut because O is the reference. O is the reference. this is the reference. So we can say that f2 is positive, sorry, and f1 is negative. I hope so that I am clear with the sign conventions, and you have just got a brief idea of concept of ray diagram also. And last thing, that the distance of the image from the object, this one, this is considered as u, and this is considered as this one, this is the v. So v is also, you can say that. A nice thing which you have to observe, that see, for you have to, in the questions you have to determine the direction of u and v also, that what is the u is positive or v is positive. See, this is the v, and you all know v is the distance of image from lens, and distance is considered from O, optical center, you know this optical center, and U is distance of object. From lens, that is O. So here, how to determine that? See, it's very easy. This is the reference point, so forget everything. This is the reference point and here is the object. So we will just go like this from here. This is our initial point, and if we go like this, this is negative, isn't it? So u is negative. Always remember, we have to start from the O, whatever the direction would be, you can easily get it. And this image, see, we will go from like this, and this is also the reference side, so v is also negative. Similarly, in case of convex lens also, it's something like this, the image like this it is formed. So wait, let's draw it exact one. This is the convex lens, and like this, something like this, and like this was like this. Say it meet here, and this is the image. So what it is, this is our optical center. Always remember one thing, this is our reference. From reference, wherever we will go, we talk everything with respect to a reference point, that is O, optical center in case of lens, and pole in case of mirror. So just start from the point of O towards the thing that you are going to determine, say the lens or the object or the height of image, everything. And for height of image, this principal axis is taken into consideration. Principal axis means if it is going like this, it's positive, and this is negative. The reference line that we draw first, that pass to the optical center in case of lens and pass to C in case of mirror. Okay, thank you. If you like, you may subscribe. Thank you.